Hey everybody, Mr. Cropper here. I'll do a quick video on the 4 types of transformations. So the first type of transformation we'll talk about is translation. And when we talk about a translation, that's a slide. So we're just moving the figure around the screen, left, right, up, down. So a couple ways you might see it done is they might just tell you a direction, left, right, up, down, and how many units. But another way you might see it is you might see it written as something like x plus 3, y minus 6. So what that means is, if it's on the x, you're going to take all the points and go right because it's a positive. If it's a y and it says something, well, in this case it says minus, that's going to tell us we're going to head down. So we take all points. So in this case, we would be going right 3 and down 6. So all points would move the same way. If you saw this, x minus 4, y plus 2, well, same kind of thing applies. So the minus 4 means I'm going left 4, and the plus 2 would mean I'm going up 2. All right? So, for example, if I had a point here, and I have to move it by, let's do the first one there. It says x plus 3, y minus 6. So I'm going to go right 3. 1, 2, 3. So I'm heading right 3. Now I'm heading down 1, 2, 3, 4, 5, and 6. And that becomes my new point. So if that was A, so I went down 6, and this would become A prime. All right? So that's your translations. All right, our next one is reflection. And that is a flip. All right? So what's going to happen is the points are going to get flipped. And remember, the rule is what's close stays close, what's far away stays far away. So this year we're dealing with a couple major kinds of reflection. And the first one that we talked about was a x-axis reflection. So that's traveling up or down. And then we also have the y-axis reflection, which means it goes from left to right. So, for example, if I have a point here and I want to reflect across the x-axis, look at how far I am from my line of reflection. In this case, so I'm going to use blue here, same color. This point is 1, 2, 3 away, so that means this side is 1, 2, 3 away. And that's a point A reflected over the x-axis. Now over the y-axis, now here's my line of reflection. So it's 1, 2, 3, 4 away, so that means it has to be 1, 2, 3, 4 away on this side. 1, 2, 3, 4. And I'm going to use a double prime here because that's my second. Alright, so remember, what's close stays close, what's far away stays far away. Now, a couple rules as shortcuts is you might see if you reflect over the x-axis, what happens is the x-coordinate stays the same, but the y changes sign. And then if you're doing a y-axis reflection, it's not the same. The x-coordinate will change signs while the y stays the same. So a couple shortcuts. Alright, our next one is rotations. And that's a turn. So on a rotation, what happens is we are turning it, and we're mainly focused on 90 degrees, which would be 1 turn, 180, which would be 2 turns, 270, 3 turns. All right? In 2 different directions, you've got your clockwise rotation, and you've got your counterclockwise rotation. So however many turns. And one rule we need to focus on is the 180 rule. So you take your x and y, and what happens to it is all the signs switch. So for example, if I'm at the point 2, 2, and I rotate 180 degrees, that means all my signs would change to -2, -2. So be right there, -2, -2, and that would be a 1, 2 turn rotation. All right? So that would have been a 90 if they'd gone here. 2 turn would have been 180. 3 turns would have been 270. That would have been clockwise. All right? Our next transformations are our final one. So we've done translation, rotation, reflection. Those 3 stay congruent. So that means everything about the shape is going to be exactly the same. The size is going to be the same. The angle is going to be made the same. Just may not be facing the same direction. With our last one, we leave congruent land, and we head to similar. And that's a dilation. So we're talking about change in size. So the key is something called a scale factor. How do we want this thing to grow or shrink? So if we want to grow, we're going to want a scale factor that is greater than 1. If we want it to shrink, we're going to look at a scale factor that's less than 1, like half the size, 2/3 the size. So if I want to dilate a point, so if I want to dilate a point 4.5, and I want to dilate it by a scale factor of 2, that means it's going to get, everything's going to get multiplied by 2. So all my coordinates times 2. So it will become 8, 10. So 4, 5, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5. And then dilated 8, 10. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Straight up my graph. So that's A, and this would be A. Alright, so that's a quick run through of the 4 types of transformations. Alright, have a good one, everybody.